Alright, welcome back to Scholar's Chat. Doing some math today. We'll be working with the natural base, the letter E. And couldn't find a note thing, so I'm just going to use a worksheet to show you how to graph these. So our parent function, y equals e to the x. That's our parent function. And our general form is y equals a e to the r times the quantity x minus h plus k. So basically everything is kind of the same. The a stretches things, the h moves it left or right, k moves it up or down. And then r just well, you'll see how it goes. So number 1, e equals negative 2x. So a is 1, r is negative 2, h is 0, and k is 0. So you just want to use usually just some simple numbers, negative 1, 0, 1. You're always going to get decimal answers when you plug this into a calculator. So for example, if I plug in negative 1 in this, I'll get negative 0.9, or sorry, negative, looking at the wrong problem, that was 7.39. So you always get decimal answers. Plug in 0, you get 1, and then if you plug in 1, you'll get 0.14. So you get something that looks like this. Negative 1 is around 7. So you get something that looks like this. Just like the exponential functions that we've been doing, just e's a little slightly different. So the domain is all real numbers. I can plug in any x value in my range. It approaches 0, so y is greater than 0, never touches 0. I can try and plug in numbers and I'll never get 0. I'll get something really low, really close, but not 0. So number 2, a is 3, r is 1, h is 0, k is 0. So if I plug in negative 1, 0, 1, these are normally the numbers you'll use. The only time it'll change is when you should use basically numbers around your h value. So my h value is 0, so I'm using 1 and negative 1. Where was I? So yeah, you're using numbers around your h value for your x's, and then you plug it into your calculator. 1.10, 0 gives me 3, and 1 gives me 8.15. Domain, all real numbers again. My range is going to be y is greater than 0. So what's going to affect... So nothing's going to affect my domain unless I start using a different type of function, like square roots. But range, the only thing that's going to affect that is my k value at this point. And hopefully we'll run into something here. So I don't want to give you too much. So I'm going to do 4 and 6. And then I'll have you do the rest. I think that's good. Yeah. So number 4. A is 1/2. R is 1. H is negative 3. So remember, still using the opposite value. And then k is telling the truth. So once again, you want to use values around your h. So my h value is negative 3. So I'm just going to say negative 3, negative 2, negative 1. So if I plug in negative 3, I'll get negative 1.5, negative 2, negative 0.64, and negative 1, 1.69. Again, all my domain is all real numbers, but my range this time is going to be y is greater than negative 2, and I'll show you that. So when I go to negative 3, I'm at negative 1.5, negative 2 is 0.64, negative 1, 1.69. So what's happening here something like this if I used more numbers. So it's approaching this dashed line here at y equals negative 3, but it never touches. Oh, it's right. Negative 2, sorry. Negative 2. Sorry. I drew this a little bit wrong. So let's redraw it again. Negative 3, 1.5. There we go. So let's do it in something like this. So it's always approaching this dashed line here. Y is equal to negative 2, but never touches. And then number 6. A is 1. R is 2. Negative 1 for H. K is negative 2. Okay. And if they ever ask you if it's a growth, remember, if it's increasing from left to right, it's a growth. If it's decreasing from left to right, it's a decay. So domain, once again, all real numbers. K is going to be y is greater than negative 2. X, just use values around your H. Negative 2, negative 1, 0. Negative 1.86. This is plugging into the calculator. Negative 1. 5.39. So there's that. And then negative 1, negative 1. Negative 2, 1.86. So again, I'm making it look like it touched, but it's not supposed to touch. Y is equal to negative 2. So hopefully that helps you in graphing these. And that's it for me.